class I am going to teach about how to write the test bench Verilog HDL code for 8:1 mux using 2:1 mux. So previous video we discussed the implementation diagram for 8:1 mux using 2:1 mux and also Verilog HDL code. If you need it, kindly refer the video. Now we move on the session. So as usual, you first write module. Then module name is mux 821 TP. So it's the module name. So already I told in test bench Verilog HDL code, input declare as register and output declare wire. So in this program, input variables are I and S. So I represent input and S represent selection line. Output variable is O. So O represent output variable. So now I am going to declare the input variable and output variable. Reg 7 down to 0 I. So 7 down to 0 I. Then reg 2 down to 0 S. So this S represent selection line. Then wire O. So this O represent output. So far we write the module and module name, then declaration of input variable reg 7 is to 0 I, reg 2 is to 0 S, and output variable declaration wire O. Then declaration of instantiations mux 821. So mux 821 is the module name. So while writing the Verilog HDL program for 8:1 mux using 2:1 mux, so here module name representation is mux underscore 821. So that name reflect here. Then DUT. So DUT represent device under test. So within a bracket, declaration of instantiations dot O. So dot O represent O. Then dot I represent I. Then dot S. So S represent S. O means output, I represent input variable, and S represent selection line variable. Then initial, begin, then declaration of input variable. So I equal to 8 B. So 8 is the 8-bit value. This B represent binary number. So let me take the input variable in 8-bit order 1 0 1 1 0 0 1 1. So it's a input variable. So it starts from here I0 to I7. So totally 8-bit of values. This LSB value represent I0, MSB value represent I7. Then after 2 nanoseconds. So after assigning this input value, so after 2 nanoseconds, the selection line value, so S equal to 3 tick B 0 0 0. So this 3 represent 3-bit value. So selection line is a 3-bit value. So S equal to S2, S1, S0. So totally 3-bit values. So initially selection line value after 2 nanoseconds, S value equal to 3 tick B 0 0 0. Then after 2 nanoseconds, this S value goes to 3 tick B 0 0 1. Then after 2 nanoseconds, S equal to 3 tick B 0 1 0. Then after 2 nanoseconds, S equal to 3 tick B 0 1 1. Then after 2 nanoseconds, S equal to 3 tick B 1 0 0. Then S equal to 3 tick B 1 0 1. After 2 nanoseconds, S equal to 3 tick B 1 1 0. Then after 2 nanoseconds, S equal to 3 tick B 1 1 1. So totally 8 combinations of input is passed every after 2 nanoseconds. Then end. So this begin end the statement. Then next initial. So now going to monitor the output. So del monitor So this statement is used to monitor the output. So here input variable is I and S, output variable is O. So O equal to percentage B. So it's a binary form of value. Then I equal to percentage B. Then S also percentage B. Then O I B. Sorry, O I S. Then initial. So finish the operation. So after 30 nanosecond, finish the function. So finish. Then finally close the module. End module. So it's a simple way of test bench Verilog HDL code for 8:1 mux using 2:1 mux. So you just remember the input variable is declared as register, output variable declared as wire. So this is the procedure to write the program. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make lot of videos. Thanks for watching my channel. Thank you.